Hey there, welcome to this exciting session in this particular series where we are going to integrate PostgreSQL into our Spring Boot application. Now, if you are new to this channel and if you're watching my video for the first time, then let me remind you that this particular video is a part of a Spring Boot series where we are building a Spring Boot application ground up, right from scratch. Okay, so if you are new to this channel, I would request you all to head over to the description of this video, get the link to the playlist and get access to all the free videos that I have uploaded. Now this will help you with some context as to what source code is being used in this particular lecture. Okay, so I would highly recommend that you should check out my previous videos as well. Now, without a further ado, let's talk about what we are going to learn in this particular session and what will be covered. So we are going to talk about how we can get PostgreSQL integrated into our Spring Boot application. And we are going to run PostgreSQL not locally, but we are going to run it as a Docker container. Okay, so we will have PostgreSQL running as a Docker container and we will have our Spring Boot application accessing it. And during the entire process, we are going to learn how you can configure and set up PostgreSQL, how you can run it as a container, what is Docker Compose, what are Docker networks, and so on. So there will be a lot of concepts that we'll be touching on, and everything would be completely hands-on, like very less theory. It's all hands-on. We directly jump into the code. Now, before jumping into the session, let me remind you to subscribe to this channel. So if you are new or if you are a regular viewer and if you have not subscribed yet, you should absolutely subscribe to this channel because every subscription motivates me a lot to bring in such free, amazing content for you all. So just hit the subscribe button, like the video and turn on the bell notifications. Now this would motivate me a lot. So just do it. And without a further ado, let's jump into the session. Welcome to this class. So let us start talking about PostgreSQL and why we should use it. So what is PostgreSQL? So PostgreSQL is an object relational database management system, or you can say ORDBMS. Okay, and it is often referred to as Postgres. So this is an database management system that places a strong emphasis on SQL compliance and extensibility. So it's free and open source, which means that it is accessible for anyone who wants to use their database for their needs. So we'll head over to the browser and here I'll search for PostgreSQL. Okay. So I'll say PostgreSQL and you'll see this official website over here. Okay, so it's postgresql.org. So I'll go to this website and you can read more about this tool over here. Okay, so it's a powerful object relational database system. Okay, and it has been in development for 35 years. Okay, and it's known for its strong reputation for reliability, robustness, and performance. Okay, so it's a quite popular database management system out there. Okay, you can check out the website and back to the slides. So why is PostgreSQL popular? So the number one reason is SQL compliance. So PostgreSQL follows the SQL standards more closely. Okay, and it makes the life easier, using which you can create more and more applications. It is also known for extensibility. So PostgreSQL allows you to define your own data types, operators, indexes, and so on. Okay. Performance. PostgreSQL has a reputation for being robust and good with performance, especially when you write complex queries. Also, PostgreSQL is known for strong community support. Okay, so since it's an open source platform, this particular database management system has a large community. Okay, and there are regular updates, improvements, and development that happens. Data integrity. So PostgreSQL has strong emphasis on data integrity. Okay, and If you are building an application that needs data integrity, so PostgreSQL might be the best choice. Let us talk about why are we choosing this particular database. So we will be moving our application to PostgreSQL. So why would we do this? Why choose PostgreSQL over H2 database? So H2 is a very capable database and has an advantage of being embedded in Java, which is really convenient. Okay. However, when it comes to building large application, like large production grade application, PostgreSQL has lots of advantages. So the number one advantage would be scalability. So PostgreSQL is really scalable and it enables you to work with high volume of data and supports lots of concurrent users. Feature set. So PostgreSQL has richer feature set as compared to that of H2. Okay, and it supports a broad range of SQL standards, data types, and functions. Ecosystem and tools. So PostgreSQL is really popular out there and it has a very broad ecosystem. Okay, it has a wide range of GUI tools like graphical user interface. You have libraries, third-party support, community support, and so on. So PostgreSQL is really ahead in the game here. Durability. So I would say PostgreSQL is much more durable and it is often the best choice for production grade environments due to its durability and robustness. While H2 is the best choice for development and testing for quick start. So to summarize, while H2 has its own use cases, okay, especially when you are building lightweight applications and doing some rapid prototyping, but PostgreSQL comes out to be more powerful, flexible, and scalable solution, making it a superior choice for developers building production grade applications. So that's about PostgreSQL. So let us understand the dependencies that we need to add to configure our job application to work with PostgreSQL. So what we are going to do is we are going to head over to our favorite website, start.spring.io. Okay. And I'm going to select Maven over here. I'm going to go to add dependencies here on the right hand side. And I'm going to search for PostgreSQL driver. Now, this is a driver dependency and it's a JDBC driver that allows Java programs to connect to PostgreSQL database. Okay, so I'll select this. We will head over to Explore. And here you will see the dependency being added for PostgreSQL. So what I'm going to do is I'm going to simply copy this dependency, head over to IntelliJ. Now in IntelliJ, here you are going to paste this particular dependency here. And this is in pom.xml. Okay. So you will get red marks, which means like you need to reload Maven changes. So here you will also see this icon appear. So I'll hit this icon and now you will see the Maven dependencies are being resolved. So yeah, once the Maven dependencies have been resolved, like you should see PostgreSQL appear normally. Okay, so the red marks have gone. So what we have done is we have added the dependency to work with PostgreSQL. So let us now configure our project to work with PostgreSQL. So we have our dependency added. Now to do some additional configuration, I will head over to main, resources and application.properties. So far, we have just added the dependency, but we need to tell our application as to where to connect, what is the database username password, and some other details which will enable our application to work with PostgreSQL. Okay. So what I'm going to do is we have here the configuration for H2 database. So I'm going to add a comment here. I'm going to say H2. Okay. Like so. And okay, and I'm going to comment all of this. So how can you add these comments on Windows? You can press Control and / on Windows and Command and / on Mac. All right. So yeah, I'll scroll down, or we can add over here itself. Okay. So I'll say PostgreSQL. Okay. Now here we are going to first define the data source. So this is the property that we'll set. So we'll say spring.datasource.url. Okay. And here we'll say JDBC :PostgreSQL, and I'll say : 2 / I'll say localhost : 5432, and I'll say /job app. So here we are saying JDBC : PostgreSQL, which means that we are using PostgreSQL database, and we are running an instance on localhost at port 5432. So this is the default port where PostgreSQL runs, and job app is the database where we will connect. Okay, so this is done. Now we need to say username and password. So I'll copy this and I'll paste it over here, and I'll say username is equal to embarkx. So you can choose the username of your choice. Okay, so I'll copy this and I'll paste this below, and I'll rename this to password, like so. So this is our username and password that we are specifying. So in short, these are credentials using which our application will authenticate itself with the database. Okay. We also need to specify spring.jpa.database, or which specifies which database we are using. So I'll say PostgreSQL. So this is the value that I have specified, PostgreSQL. Then we need to say spring.jpa show SQL. So this is a property that we had set with H2 database. So we are going to set this to true again. And this setting is useful in development, and the reason is because of this setting, Hibernate is going to print all the SQL statement onto the console. So Hibernate is a JPA implementation. Okay, so it is going to print everything onto the console. And then we are going to have this property as well, which talks about whether the database should be created or updated. Okay, so we can say create drop for now. Okay, so this tells Hibernate or JPA to automatically create and drop the database schema based on the entity class. Okay, and create drop means that the schema will be created when this session is created, and it will be dropped when it's destroyed. Okay. Now we need to also mention the database platform. So we'll say spring.jpa.database. So database - platform. Now here we will be specifying the dialect. So this tells Hibernate which dialect it should use. Okay. Now what is a dialect? So dialect is a configuration of SQL generation. Okay. And it varies from database to database. So since we are using PostgreSQL, we will say we want to use org.hibernate.dialect. So you can see different suggestions here. So I'll say PostgreSQL dialect. PostgreSQL. You can see there are a lot of suggestions over here. So if you say SQL Server, you have SQL Server dialect as well. Okay. So I'll say PostgreSQL dialect. So this is a dialect that I'm specifying here. Okay. So yeah, here is the auto suggest. Okay. So this is the one we are using. All right. So these are the settings that we need to do in order to configure our database to work with PostgreSQL. So I hope you have a clarity of each and every setting. Okay. And I hope you have configured the same for yourself as well. Welcome to this class. So let us start talking about Docker networks. So we would be discussing Docker networks with the help of two Docker images that we would use. So one image we would use of PostgreSQL. So this is a database that we are going to need using which our application is going to interact. Okay, so it will host our database which our job app is going to interact with. This is one image that we are going to get, and then we are also going to need a PGAdmin, which is PostgreSQL admin. So this is an admin panel that you get to work with PostgreSQL, and it is one of the most popular open source like administration tool, okay, for PostgreSQL. Okay, and it's being used by a lot of developers out there and a lot of companies as well. Okay, and you can see it works with different platform here. So you can read more on this website. So if you search for PGAdmin, you will be taken to this website, which is pgadmin.org. And if you hover on the screenshot, like you will see this image come up, and this is what PGAdmin looks like. Okay. So what we are going to do is we are going to take these two images and we are going to talk about the concept of Docker networks. So what is a Docker network? So Docker network allows a communication between multiple Docker containers. So if you are running multiple containers and if they need to communicate with each other, you will need to make use of this concept called Docker network. And as the name suggests, it's a network that works with Docker containers. Okay. So using this network, we are going to communicate across the containers. All right. But let us understand how this works. Okay. So what I'm going to do is I am going to head over to IntelliJ and I'm going to open up the inbuilt terminal. You can use any terminal of your choice, like if you're using some other operating system or like if you're using Windows, Linux or Mac, you can use any terminal, but just make sure you are inside the root directory of your project. So you can run Docker commands from anywhere in the system as long as you have the Docker app running. So this Docker desktop is running. So I can use Docker commands from literally anywhere. But there is a reason why I tell my students to run the commands from the project root folder is because if you're building images, so images, I mean image of your application that you have created. So if you need to create an image for this job application that we create, you need to be in the root folder. Okay. It's just best if you are in the root folder and if you use that as your main working directory on the terminal as well. So that really helps. And with IntelliJ, if you open up the terminal, you are by default logged in to the root directory as you can see over here. All right. So this is about terminals. Okay. You can use any terminal of your choice. So I'll be using IntelliJ terminal over here. Okay. Now what we can do is I'll use Docker run command. Okay. So if I say Docker images, I'm going to get the list of all the images. I don't have an image for PostgreSQL. Okay. So what I'm going to do is I'm going to say Docker run. I'm going to say -d because I want this image to run in the detach mode. Okay. I'll say name over here and the name will be DB. So that is the name that I'm going to give. Okay. I'll say -e and I'm going to set some parameters over here. So I'm going to say Postgres _ password. So this is a password that we are setting. Okay. And -e allows us to set environmental variables that the PostgreSQL image uses. And here we are using the environmental variable to set the database password. Okay, so I say Postgres password is equal to like my secret password. So I'll just enter password, or you can just enter a password, say, of your choice. So I'll enter this password, right? And now what you can say is you can specify which image you want to run. Okay, so this is the image name Postgres. Now I'll say enter. Now the moment I say enter, you will see this message like enable to find the image Postgres latest. So we have not specified which version we want. So you can specify the tag or the version after a colon here. But if you don't specify that, it will by default pull the latest. And you can see it pulled latest. And it was also able to detect that we don't have the image locally, because when we did Docker images, we didn't find the image locally. Okay, so what it did is it pulled the image for us. Okay, so the pulling was complete and it started the image as the container. So it started the container from the image. Now if we say docker ps, not hyphen, so you're going to see this container is up and running with the name db. Okay, so this is a Docker container that I have now. Now I need to run a second container. Okay, and this is of PGAdmin. So I can say docker run -t. Okay, and now I'm going to specify the name. I'm going to say PGAdmin, like so. I'm going to say -e, and I'm going to type in PGAdmin _ default email, and the default email is admin@admin.com, something like this. So I'm just setting up some hypothetical email over here. Okay, I'll say -e, and I'll say PGAdmin _ default _ password. So here we are setting the password. Okay, and I can say the password as this one. Okay, and then I need to get the PGAdmin image. So I can say /PGAdmin, like so. Now I'll press enter. Okay, let us see what happens. So it will again say that it cannot find the image locally, and we got the error. Okay. So this image was not pulled and we got an error. So I'll change the image name to PGAdmin4. Okay, and you will see that the image was pulled. Okay, and it worked. So I can say docker images, you have the image now, PGAdmin4, and if you say docker ps, you will see like the image is running. Okay, now let us see if we are able to communicate across containers. Okay, so these are two containers that are running right now. Okay, now I have a notepad over here. Okay, wherein I have all the commands written. Okay, you can see all the commands here. Okay, now what I will do is I'll run this command. So this first part of the command allows us, so docker exe allows us to execute command in a Docker container. And when we say IT, we are making use of interactive console. So input and output, we are making use of input output of a particular container. And then we specify the container name. So here is where we are executing the command. And this is the command that we are executing. So we are saying ping this particular container. So essentially we are saying from PGAdmin container, ping database container. Now what is ping? So ping command, if you're not aware of, it's a tool essentially to check the reachability of a network. Okay, whether a device is connected to a particular network. So it checks if we are able to communicate with this particular container over here. Okay, so I'm going to copy this docker exe it pgadmin, and here in IntelliJ I'm going to paste this and I'll press enter. So of course you get an error, bad address db, which was expected because you don't have network connectivity between these two containers. Okay, now what we need to do is we need to remove both the containers over here. Okay, so I'll remove both the containers. So I'll say rm-f, which is force, remove db and pgadmin container. Okay, so we tested how like Docker container cannot communicate without a Docker network. Okay, so now I remove these two. Okay, now if I say docker ps, you don't have any running containers. So first we need to create a Docker network. I'll create a Docker network using this command. Okay, so I'll head over to, let's say, IntelliJ. I'll paste this. Okay, and we have a Docker network created. Okay, now what we need to do is we need to say docker run And now I'm running the same command. So here initially I run an instance of Postgres. Okay. So I'm running an instance of Postgres again, but this time I'm adding this value over here. So I'm saying network, my network. All right. So I'm going to copy this and I'm going to run this. So I'll say paste, enter. So we have this container now running, but this time it is making use of my network, okay, which is the network that we just created using this particular command here. Okay. Now I'll even run the PGAdmin with the help of network. Okay. So I'll run this again, PGAdmin 4. We have this running. Now if I say docker ps, you will see both these containers are up and running. Now what I need to do is I need to run the ping command again, okay, in a similar way like I did earlier. So I'll say paste over here and I'll say enter. And this time you can see like the network information, it's working fine. So earlier, if you scroll up, we got bad address, and that is because they were not on the same network. But this time we are making use of a network. So I'll stop this, otherwise it will continue going. But you can see there were 18 packets that were transmitted and received through the network. Okay, and we tried communicating from PGAdmin to that of DB. Okay, so this illustrates that when containers are in same network, they can communicate with each other using the container names as host names. So here we made use of container names. So ping DB. So DB is nothing but a container. So if you say docker ps, you will see a container with this name running. Okay. So we used container name as host name and we saw an output with the help of ping command. And what is ping command? It's a tool to check network reachability for a particular host. Okay. And it's a quick way to verify that whether we can reach out a container or a device over the network. Okay. Which is very vital if you wish to interact in future. Okay. Now, why do you need to communicate across containers, you will ask? Well, it's really important to do communication across containers. The reason is we have PostgreSQL running on a container, right? So here we have two containers. So this is PGAdmin and Postgres. So they both are running right now, but how do you communicate? So PGAdmin needs database. So it's a admin tool, DB admin tool, right? So it will have to connect to the database, which is PostgreSQL. So how would it create a connection? Because Postgres is running on a different container. And for that, we need Docker networks. And Docker networks is an amazing tool, okay, to help you communicate across containers. So that's about Docker networks in a practical way for you. Welcome back. So I wanted to introduce you all to some more parameters when you create PostgreSQL and PGAdmin and when you run it as a container. Okay. So this is the updated set of commands that we should use in order to make use of PostgreSQL. So here, like -d stands for running the container in detach mode. You have the name of the container that you have specified here. Okay. So I've changed the name to Postgres_container. Then you have the username and password setup. And here we are also setting up PG data. Now this specifies the data directory for PostgreSQL. Okay. And here we are even specifying a volume with the help of -v command. So -v mounts a Docker volume named Postgres to this particular path. And this is a path within the container. This is used to persist the PostgreSQL data. Since we'll be working with data, so we need this volume. And I also need to map the container's port to our local host so that we can work with it. So I've said -p, which is the parameter that you can use to map the container's port. So here I've said 5432 on host should be mapped to 5432 within the container.
And then I have added this particular container to this network, Postgres, and I have specified restart unless stopped, which means that the container should be automatically restarted unless explicitly stopped. And here I have the Docker image name. Okay, so this is the updated list of commands. Okay, you can customize the parameters if you need, like you can customize the name and all if you need to, but these are the parameters that we should use to run Postgres. We also have the similar command for PGAdmin, wherein we are even mapping the port over here. Like 5050 on localhost is mapped to 8080 within the container. And 8080 is where the PGAdmin service will run within the container. Okay, so I've specified these parameters and we will see these parameters in action. Well, we took a look at the configuration that we need to do for our Docker containers. And well, it's a matter of time that our application grows and we need to create a lot more container for using a lot more services in our application. So with growing list of containers, how do you manage them? So do you manage them all with the command line? Yes, you can run Docker commands and manage your containers from the command line, but there is a better way to manage your Docker containers. And let's talk about this amazing tool called Docker Compose. So Docker Compose is a tool for defining and managing multi-container Docker application. Okay. So you as a developer can define all the containers that you wish to have for your application. And with a simple command, you can run all your containers at one go. So here we have to manually run all these commands with all these configuration. And if anything changes, we have to rewrite the command. You have to make sure you save these commands in Notepad and so on. But I don't want to manage things this way. So Docker Compose is a brilliant tool that enables us to manage all of this efficiently. So what you have to do is you have to create a Docker Compose file, which is a YAML file, and you can define the configuration of different Docker containers. And these containers will be run as a service. And within that single file, you can define everything related to Docker. So you can have your container definition, you can have the network definition, volumes, and so on. Okay. So I have an example Docker Compose file, which I have created using these commands. Okay. So let me open the file here. So this is the file for Docker Compose. Okay. So this is Docker Compose.yaml. It starts and looks like this. Okay. So it starts with service tag. And let us talk about each of the tags that we have over here. So we have services tags, okay, which is used to define services. So this is a keyword that exists and it is used to define the services that makes up your app. Okay. Now services are nothing but containers in Docker. Each service that you define runs as a container. So if, for example, under service tag, you can see this is one service and this is another service. So there are two services that exist. Okay. So after service, you have the containers, okay, that you wish to create. So these are all the container definition that exists. And within Postgres, so you are saying over here, the container name, the image, the environmental variables that you are setting, the environment that you are creating, the volumes, the ports, networks, and some other parameters if you wish to specify. So you can specify all your configuration this way and you can run this with a single command. So what will happen is in the older approach wherein you had to run all of this individually. So you have to run this command, then run this command. And if you want to stop anything, you have to go and stop manually. Okay, so you have to run those many stop commands for every container that you have. And let's say if you're building a huge application and if you have like tens and 20 or like hundreds of containers that you're running, it becomes cumbersome. Okay. So Docker Compose makes your life easy. So you have the single file with which you manage everything. You have the network definition here at the bottom, and here you have the volume as well. So the volume definition is also something that you have mentioned. So I'll copy this entire file. We'll head over to IntelliJ. I'll minimize this terminal, and here in the root folder, so here I'll say new, I'll say file, and I'll create a file. I'll say docker -compose.yaml. Now this is a YAML file that is created, and with this you will also see an option to install Docker plugin. Okay, so you can install if you wish to. Okay, so I'll get this installed. So you can see IntelliJ has some good support for Docker as well. Okay, so I'll minimize this. We have the YAML file here. I'll paste the configuration that I just created. Okay, and you can see with the help of this plugin, now you can see we have the option to run this particular service right from here without the command. Okay, so if you just hover on this, you will see the command docker compose up. So this is the command that you have to run this entire file with the help of docker compose. Okay, so if you want to start all the containers that you have defined, you need to say docker compose up. Okay, so you can see this command coming up, docker compose up. And if you want to run it in detach mode, you can say docker compose up -d. Okay, and if you want to run a single service, you can say docker compose up Postgres, the service name you have to specify, and the service name is Postgres. Okay, so this is a really good tool, and it allows us to work efficiently with Docker containers. So I'm going to save this, and I'm going to head over to PowerShell. Okay, so here I'm in the root project directory. Okay, and if I say ls, I have, okay, I'll head over to first job app. And if I say ls, I have docker compose.yaml. So you need to head over to the directory where you have created the docker compose file, and you need to say docker compose up. Okay, now the moment you say this, okay, docker compose is not a command. So I'll run this command again. Okay, I'll say docker compose up. And when you run this command, you will see PGAdmin is being pulled and Postgres is also being pulled, and it is being pulled in form of layers. So you can see over here. Okay, and you will see the entire status appearing. So initially the command didn't run docker compose, so it was not being identified because there was an issue with Docker installation on my system. So I just uninstalled Docker completely and installed a fresh download. Okay, and once I did that, I started Docker engine, like Docker desktop, and then I have the command running. So for Docker compose to work, so Docker compose is a separate tool, but it comes inbuilt with Docker desktop. Okay, so if you have Docker desktop installed, Docker compose should work for you. Okay, and once you run this command, you will see the entire processing being done. So first the image was pulled, like these two images, then the network was created, then the volume was created, then this volume was also created, and then after doing this, container was created. Okay, and then the containers were attached. Okay, and then all the processing happened. So you can go through the entire stack trace. Okay, and you can see what all happened. Okay, so you'll see the entire processing happened. Okay, so everything worked fine, and this is Docker compose. So right now we have run Docker compose, but we have not run it in detach mode. So what you can do is we won't be able to use this terminal. So because we have not run it in detach mode, so whatever logs appear, they'll appear here in real time. So I'll stop. I'll say Control C, or if you're on Mac, you can press Command C, and it will forcefully stop the container. You can run this in detach mode. Okay, but before running, I'll check Docker PS. So none of the containers are running. Docker image. Okay, sorry, Docker images, and you will get 2 images over here. Okay. Now what I can do is I can run docker compose up -d, and this will run this in detach mode. So you can see it has started in detach mode, and you can say docker ps to check if the containers are running. Now the question is, how do you check for logs? So here, when you don't run in detach mode, you can see the logs. Okay, you can see all the logs, what is happening. Now let's say I want to check logs for a particular container. So you can copy the container name. So Postgres_container, and you can say docker logs and paste the container name. And this will show you all the logs that has happened for that particular container. Okay, so isn't this wonderful? Docker Compose is one of the wonderful tools to work with Docker, and I highly recommend using it. So you can see how with a single file, which is dockercompose.yaml, you have everything defined over here. Okay. Now imagine doing this like in the terminal, like running all of these parameters in terminal. Okay, you would have to create a notepad file, and you would have to save all the commands that you're executing so that you can reuse them later on. Okay, it's really cumbersome, but this makes your life much more easier. So with terminals, you also have to make sure like you create networks first, then you define volumes, and then you attach the volume and so on. So you have to be in sequence when you're working with terminal. But with docker compose.yaml, you just specify what you want, and Docker Compose takes care of everything. Okay, and it's a really useful tool, and you will often hear Docker Compose when you're working with Docker. So that's Docker Compose for you. Well, now that we have our containers running, so you can see Docker ps, and you'll see the container is running. Now we should access PGAdmin from localhost, and we could work on creating the databases. Okay, so you can see over here, localhost colon 5050 port is mapped to PGAdmin within container 80 port. So you should be able to access PGAdmin dashboard with this port over here. Okay, so I'll copy this and I'll head over to my browser, and I'll say localhost colon 5050. Okay, and I'll say enter. So you can see we get the welcome screen. All right, now here it's asking us to set a master password for PGAdmin, and this will be used to secure and later unlocked safe passwords and other credentials. So just be careful of what you're setting over here. I'll set a password for myself, a simple one that I can remember. So I'll say OK. And now here you have this dashboard. So for our application, if you head over to application.properties, you will see this configuration for PostgreSQL. So we have specified that we need this database job app with username embarkx and embarkx. So I'll create this particular database in PostgreSQL with the help of PGAdmin. So back to our browser. Here, I'm going to say create, and or instead of right clicking here, you can even click on this link over here, add a new server. So we need to add a server, okay, and we need to specify the credentials. Okay, so I'm going to say Postgres container, like so. You can specify any name here. Then we go to connection tab. We'll say Postgres as the host name because that is what the host name is. Okay, so that's the service name with which we are going to access it. 5432 is the port. Okay, maintenance database, I'll leave it as default. Username, I'll keep it as this username here. Okay, and the password also I'll specify here, and I'll say save. Okay, now the moment you say save, you will see this connection appear over here, and if you expand on this, you will see the list of the databases over here. Okay, so you have this database coming up over here. Now we need to create a database here. So I need to say database, and the database name is job app. Okay, I'll say save. Okay, this database is created, and you can see everything around this database here. So you have different objects, and here you have schema. So if you click on this, you will see this open up like the public schema, and you can go over here and expand these tables tab. So there are no tables right now created, okay, but you will see the tables information appear over here. And this is a general dashboard for what is happening on the server, okay, on the database server. So it gives a very nice view to see what all is happening on your server. So transactions per second, tuples in, tuples out, okay, the database sessions, and so on. Okay, so there is one active database session, which is us. So you can really use this as a tool to monitor and manage your PostgreSQL database. So this is how you can access the PGAdmin interface, and this PGAdmin interface is something that is running in the container. We have not installed PGAdmin onto our system. We have not installed PostgreSQL onto our system. Okay, everything is running within a Docker container, and we are using localhost :5050 port, which we have mapped to the default port where PGAdmin is running within the container, and we are able to do the magic. Okay, we have in fact also connected to the database now, like the PostgreSQL database server, and we have created a database within that server. So it's amazing. So that's about PGAdmin. So with our database setup, I'm really eager to start our application and see the application running on the PostgreSQL database. Okay, so let us run our application and let us see if we are able to successfully run this application or we land up in errors. So I'll click on this run icon at the top. Okay, and we will see the application starting. Okay, so we will wait for a while and we should see. Okay, so the application has started fine. Okay, there were no issues as such. Let us head over to PGAdmin and let us see if the tables were created successfully. Okay, so when you start the application, you should see the tables being created here. So I'll say right click and we will have to refresh here to refresh the information. And the moment you refresh, you will see 3 tables appear. One is the company, the job, and the review. And if you expand each one of them, you can see the columns as well. So here you have columns, constraints, indexes, and other objects. Or if you don't want to use this view, you can say company. You can right click on company or the table that you want to, and you can say view or edit data, and you can see all rows over here. Okay, so you will see this query being automatically executed and you will see the rows appear over here. So right now we don't have any data that exists in this particular table. So we are seeing 0 rows of 0. Okay, but we are seeing the columns here. So we have ID, which is primary key, and it's of big int type. We have description, which is of character type, name, which is of character type, and it's of varying character type, which is varchar. So yeah, table setup is done completely fine, which means our application is now able to talk to the database that is running within the container. And this is a Docker container where PostgreSQL database is running. Okay, now let us try creating some companies, some jobs, and even some reviews with the help of Postman. So here, if I try to get a list of all the jobs, of course, I'm going to get an empty list. So let me create my first company right now. So I'll create this company here. I'll say company 1 and description 1. So if you go over here, we had empty company table. Now, if I say this post request, let us fire this, you'll see company added successfully. And if you come over here and if you rerun this query, so I can like click on this run button, or you can go back here, refresh and say view audited data. But I'll say rerun, and you will see the company data appear over here. Okay, so this is working perfectly fine. Now let me create a job, or let me create one more company. So I'll have two companies. Okay, I'll send this post request, and then I'll create a job. Okay, so I'll create a job against the company ID 1. I'll say software engineer needed 1. You send this, you get 201 created. Okay, 201. I'll create another job. Okay, and this time against company 2. I'll send this, and you see job added successfully. I'll even add a review. So I'll say review 1. Okay, I'll send this, and then I'll run review 2, and I'll send this. Okay, now let us get everything. So let us try to get all the jobs. You can see you have the JSON of all the jobs with company, reviews. Okay, you have the second job with second company but no reviews, because both the reviews that we added were against the company 1. Okay, you can even get the company from here. Okay, so I can get the list of companies. So the moment I run this, you will see like the company information come up. Okay, and reviews also should work fine. Now if you go to PGAdmin, and if I refresh everything, okay, now if I run this company table query, you will see 2 company here. Let us see the review information or job information first. So you will see there are 2 jobs that have been added, and they are added against 2 companies. We can even run for review. You can see there are 2 reviews that have been added with the rating that of 5. So we have successfully set up our application working with PostgreSQL. So our application has been able to connect to PostgreSQL, and it's working really, really well. We are seeing all the queries being executed via Postman, and the data is being entered into this database. Okay, so that's about this class. I shall see you all soon. Thank you.